Good morning, everyone, or afternoon if you are on the East Coast. We are very happy to have you for our webinar this morning. We're going to be talking about how to increase MRF efficiency and minimizing contamination. So this is definitely a hot topic, and I'm looking forward to going through this with you guys today. So before we get started, I just want to go over a couple of housekeeping items. So my name is Sarah Bolton. I'm the new Business Development Manager here at Blue Ridge Services, and I will also be the webinar moderator for today. You can email me at any time, Sarah, S-A-R-A-H, at blueridgeservices.com, and I'm happy to answer any questions you have after the webinar, or if there's additional information you would like to request, you can always reach out to me there. So just to go over a couple of things about your control panel. So when you log in to GoToWebinar, you will see a control panel that probably looks something like this. If you don't see this full control panel, you can click the orange button at the top of this little mini panel, and it should open up the full control panel. So a couple of things to be aware of. There are two options for audio. You're either using your computer's mic and speakers, or you've called in through your phone. Just make sure you have the correct option chosen on your control panel that matches whatever audio source you're using. We really like for our webinars to be interactive, and we appreciate your comments and questions. So at any time, you can start sending questions through the questions tab on your control panel. Or if you have a comment to add or something to add to the conversation, please don't hesitate to do that. We will take time at the end of the presentation to go over any questions and make sure we get those answered. So make sure to send those in if you have them. We will also be sending out a full recording of today's webinar, as well as any handouts that we discuss. So if you want to watch again or share with a coworker, you can do that because you'll have the full recording. And this is for anybody who might be having audio issues. You can always send me a message in the questions or the chat box, and I can help you out with that. If you see this timer in the middle of your screen, you can just kind of click and drag it out of the way. Sometimes it's there, sometimes it's not, but if it's in your way, just kind of click and drag it with your mouse. And we have another webinar coming up next week on September 24th at 10 a.m. Pacific time, and it's going to drill down a little bit deeper into MRF operations and talk about some of the commodities that you might be focusing on. Are those the right things to focus on? So again, we're going to look at sort of the first step in the process today, and then next week we're going to drill down a little bit deeper. So if you haven't already signed up for this, I recommend jumping on that one. Even if you know you can't attend, just like today, we will send out the full recording, and I think both of these are going to fit together in a nice sort of sequence showing this process, so I definitely recommend you do that. And I will send out the link to this in the follow-up email as well, so if you don't have that, that will go out with the recording. All right, so I'm going to turn things over to our presenter, Neil Bolton.
Hello, Sarah. Can you hear me okay?
Yep, loud and clear.
Let me know when you see the title screen and we'll get started.
I see it. You're all set.
All right. Well, welcome, everyone. It's kind of an intense topic today. We hear a lot about recycling industry being in the doldrums right now, and certainly that's the case throughout much of North America. And we're going to talk about some of the things that are contributing to that and some solutions if you want to make things better for your recycling program. So again, today we're going to talk about how to increase MRF efficiency by minimizing contamination. But this is more than just about MRFs. This is about any type of diversion program that you may have in play, whether that's organics or a MRF or metals or whatever else you might be doing. It's not just for MRFs, although we will talk a lot about MRF processes and MRF examples. So Sarah is our organizer. We're going to have question and answer at the end, and as she said, if you have questions, there are different ways you can ask those questions. Our goal is that this be interactive, and we are doing our best to get good information out there to the industry. You know, we have a lot of regulators and users and even lots of other consultants out there who jump on here to try to hear maybe what we've learned or how we approach specific things, or just to find solutions for some of the problems that our industry is facing right now. So welcome to all of you, and the goal is that we can figure things out. My name is Neil Bolton. I have more than 42 years experience, soon to be 43 years experience in heavy construction and the waste industry. We do work all over North America and have done a lot of work abroad as well. My first involvement on large-scale recycling was as a project manager for a remodel or renovation of a big recycling facility in 1984. And at that time, recycling was not the cool thing to do. It was just a business. And if you could make money at it, it made sense. If you couldn't make money, it didn't make sense. Now we see a lot of recycling that is done because it is the cool thing to do, because it is maybe mandated by legislation. Maybe there's political pressure or public pressure to recycle. And in some ways, we get things upside down. But this whole issue of contamination has been an issue as long as I've been in the business. And even when I was working on that renovation project for that big recycling facility, they did a lot of paper buyback at that time. And we saw things, loads of paper and cardboard and office paper, all sorts of things coming in, along with hidden bowling balls and chunks of concrete and buckets of water, anything that added weight, because folks who brought recyclables into this facility were in the business to make money too. So they were, some of them fudged with how they got weighed and paid, and so the crew at the recycling facility had to be on the lookout to make sure that it was actually functioning as a business and we were getting what we were paying for. Contamination is a major problem, and it's a contributor to China's national sword. It is a major contributor to our industry's current recycling crisis, and it is a chronic loss of revenue for you. And we'll talk about how we can deal with that. We have 4 poll questions today, and these are to give all the folks that are in attendance an opportunity to participate and also to see what's happening within our small group. And I think there are enough folks here today to give us a bit of a cross-section and a look into what the industry is thinking. So the first question here is, how would you describe contamination within your recycling program? And this can be a MRF, a compost operation, any diversion activity. How would you describe contamination? Number 1, slight contamination doesn't impact price or marketability. Or number 2, moderate contamination doesn't impact price or marketability. Number 3, significant contamination that is impacting price and marketability of your product. Number 4, major contamination to the point that some products are non-marketable. So again, the question, how would you describe contamination within your recycling program? Number 1, slight contamination doesn't impact price, marketability. Number 2, moderate contamination. Number 3, significant contamination that's impacting price and marketability. And number 4, major contamination to the point that some products are simply not marketable.
Okay, great. So I already see lots of you guys are jumping in on this question. Just to let you know, these we're going to do 4 of these today, and they are completely anonymous, and you're not required to participate if you'd rather sit out. But it is really interesting just to see our group today and kind of get an idea of where everybody's at across the industry. So definitely jump in if you feel like you want to do that. I still see some answers coming in, so I'm going to give just a few more seconds. And in the meantime, welcome to anybody who maybe jumped on a couple minutes late. No worries. We're going to send out a full recording of the webinar today, so if you missed the first part, you'll have a chance to go back and listen to it again when we send that recording out. All right, I'm going to go ahead and close out this webinar, or this poll, excuse me, and share the results. So we have 0% of us are dealing with slight contamination. 19% have moderate contamination. Our largest percentage today, 63, have significant contamination, and 19% have major contamination.
Wow, these are hard numbers, but it tells us where we are in the industry. And this is not something that just happened overnight, and we don't need to be completely surprised by that. Contamination is something that can originate any place in the waste processing, in the waste process, basically, in the whole waste management process. It can happen at the source. It can happen while sorting, while floor sorting. It can happen post-sorting. Contamination is a big deal, and it has multiple results, it impacts our ability to move product, and it also reduces the price, the revenue that we're going to generate from those particular products. Um, here's the bad news. If you think there was bad, maybe this is the worst news. Higher standards are coming, and I'm not talking about regulatory standards. I'm talking about higher standards for you to be able to move your product. Think about what's happening. Let's think tank this for a minute. Get big picture. The industry is still continuing to recycle. Contamination is an issue. Many of our markets have dried up, so we end up with a higher supply than there is demand. And when that happens, those who are buying materials, think about a paper mill or someone who is actually buying feedstock from recycling facilities, they can get their material for a very low price, which impacts your revenue, and they can demand a very, very high quality, which can also impact your operation. So these facilities can be extremely picky because there's more supply than there is demand. So one solution is you can reduce contamination by slowing the pick line, or in general just slowing down your process. But doing that and then adding more people, more hours to the process, does that really help when the model's already upside down? Probably not. So if you have a green waste or a compost operation, you can spread that material out and you can send laborers out there to pick through all of that material to pull out all the plastic and anything that looks like contamination. Or on your MRF, you can slow the pick line, you can add more pickers. That's going to add to your cost. It may help solve some of the contamination, but are we really getting to the root issue? And that's the big question. Contamination doesn't just happen. It's not something that, oh my gosh, one day I went out to the MRF and there is contamination there. There are underlying causes. There are reasons for contamination. I'm not talking philosophical reasons. I'm talking about real nuts and bolts root causes for why contamination is occurring in our recycling process. Often you can look upstream and you can find that at the point of origin where your residents are putting recyclables in one bin and trash in another. Maybe they're not educated. Maybe they're not doing a great job with that process. And one of the things that we see with that is that in an effort to push recycling, many municipalities offer different programs for their garbage collection. So let's suppose that you're a resident and you have a choice. You can spend $50 a month for the big garbage can, or you can spend less money for the small garbage can. And municipalities often try to motivate people to recycle by making that smaller can a little bit cheaper. So there's a smaller can for trash to try to force people to generate less trash. Problem is, they may choose the small can because it's cheap, but what do they do when that small trash can gets full because it's really not big enough for the trash they're generating? They end up putting marginal materials or even trash in the recycling bin. So there are things that we're doing upstream of the MRF that may be causing some of those problems. That can happen at the point of origin. It can happen during collections. It can happen on the MRF floor. We're going to talk about some of those things. But if you think about it and you're successful in identifying those root causes, you don't have to spend a ton of money to reduce contamination. Sometimes it's going to cost money, but oftentimes it's just a matter of identifying the source and then fixing that. And it doesn't always take money and more people to do that. Most MRF managers know that they have a contamination problem. Our survey just showed that. They may have an idea of where it is coming from, but for a real change, we have to drill deeper into the process to find out why and where it is happening. This takes us to poll question number 2. What steps have you taken? So we just saw that more than 80% of our group here today is having a serious problem with contamination. What steps have we taken to minimize contamination? Number 1, added more staff. Number 2, changed our sorting procedures. Number 3, modified our equipment or the material flow. Or number 4, really very little because we're not sure what to do. So again, the question, what steps have you taken to minimize contamination? Number 1, added more staff. Number 2, changed our sorting procedures. Number 3, modified our equipment and material flow. Or number 4, really very little because we're not sure what to do.
Okay, great. So I still see some of you are jumping in on this poll question. So if you would like to comment on this one, go ahead and jump in and get your answer chosen. And also, as we progress through the webinar, don't forget you can start sending your questions in at any time. So if you go to your GoToWebinar control panel, there's a tab that says questions, and you can just type it in there and send it, and I will keep track of those, and we'll get to those at the end of the presentation. All right, so I'm going to give just a few more seconds here for everybody to get their answer logged in. And then I'm going to go ahead and close that out. All right, so 9% of us are adding more staff. 27% are changing their sorting procedures. 9% have modified equipment or the flow of materials. And 55% of us have done very little, and they're not really sure what to do to address this issue.
Okay, so this is, again, very telling. And I'm just going to reach back to the first poll where we had 63% of us saying that contamination is a serious issue at our facility, impacting our revenue. And then, so most of us are having a serious problem with it, and most of us here aren't sure what to do about it. So again, this is what we're going to be talking about today. And this is part of the quandary out there, and is that historically, when we created recycling programs, so think back to the origin of your recycling program, you weren't too concerned about a little bit of contamination because you were working on getting your numbers up. You wanted to reach those high diversion numbers. I get to do work all over North America. I live in California right now, which has a very aggressive mandated recycling program or recycling goals. The state mandates that recycling occur. So I can be in other states, and I often am talking to other folks, and even in different Canadian provinces, and they'll say, "Hey, what can we do to match California's great recycling results?" And I'll say, "Be careful what you do, because some of those numbers are not real and they're not financially sustainable." And that's what we're finding out here. So we haven't really focused as much on how do we deal with contamination and how do we make a pure, clean product as we have on maximizing revenue or rather maximizing diversion with little regard to revenue. So now we're having to rethink how we do things. I want to share how we deal with it, because people say, "Hey, how do you guys do this?" Our company, we are operations consultants. We have civil engineers and mechanical engineers and process improvement folks and a lot of hands-on folks. And our gig in the waste industry, what we do is operational consulting and efficiency type analysis, safety, efficiency, process improvement. Often people ask us, "How do you deal with this? How are we going to fix this problem?" And so what we do is generally conduct some type of a core assessment. Core is an acronym for Comprehensive Operations Review. It's actually a trademark of our company. And this is what goes into a core. If we came to your MRF or your recycling facility and did a core assessment, we'd spend a week or two or more on site, evaluating, filming, monitoring, measuring, talking, investigating. Then we'd spend several weeks in our office analyzing all that data and going through a whole bunch of just analytical processes. I'll talk about some of those in a bit. And we'll integrate the years of experience we have at hundreds of facilities. We'll go through a bunch of analyses. We basically follow this thought process of process improvement. And I have a link here. This will be on your file that Sarah sends to you. If you click this link, you can download a free PDF book on process improvement that we wrote for waste operations. So we'll do these steps to assess what's happening. A core, comprehensive operations, it's not benchmarking. That's metrics. That's how you monitor. A core helps us drill down to find what those root causes are. Here's a very basic example that probably has nothing to do with contamination, but it's a simple example. Let's suppose that your baled recyclables in your MRF are not stacking properly. The bales are leaning. If you get more than 2 bales high, they want to fall over. Well, why is that happening? Maybe the floor is not level, or the forklift operator's in a rush, or he's not trained, or the bales aren't symmetrical. And you say, "Yeah, you know what? They're not symmetrical. Why is that happening? The baler's malfunctioning. We have a loose wire tie system. Maybe the conveyor is not feeding symmetrically into the baler. It's running too fast. We need to realign it." And you drill down and down and down until you find what the root cause is. And we were working at a MRF recently where the bales were coming out lopsided, and it's because the conveyor was just feeding into one side of the baler more than toward the other side, so the bales were forming in an unsymmetrical way. They weren't stacking properly. So a core goes through this whole process to help us identify the root causes. That's the bottom line. We're looking at root causes. And so we may take all the data that we find in a core assessment, run that through a pretty sophisticated model that we have that may have 100 or more interconnected worksheets. So example, if we decide, hey, let's see what happens to the impact if fuel prices go up or go down, that will replicate throughout the entire model to show us what the impacts. Same way, what if we made a change in one part of the operation to reduce contamination? How would that impact everything else? And so it's an interactive thing. Basically, a core assessment helps us get to our ultimate goal of solving problems and increasing efficiency. In essence, once we're done with this, facilities have a reference book that's just geared for their site that tells them, here are your problems and here are some solutions you can look at to cut costs and improve that. So anyway, that's what a core assessment is. Here's an example. I want to take you through an example of the kind of thing we might do on a core assessment and how it might apply to this issue of contamination. So one particular tool that we use when conducting a core assessment is a cause and effect diagram. Sometimes that's referred to as a fishbone diagram. In a couple minutes, you'll see why it might be called a fishbone diagram. In this example, the goal is today's topic, how to reduce contamination, or we have a problem of excessive contamination of recyclables. But before we begin, let's talk about how this usually goes. Your customers tell you that your loads have too much contamination. It might impact your price. Maybe one or more loads or even shipments have actually been rejected. So the manager tells the crew, hey, we've got too much contamination. You need to do a better job on the pick line. That's like a football coach telling the team, come on, guys, get out there and win this game, without giving them any specific tools or insight into how to do it. Talk is talk. When you drill down, you can actually have action. So you might even have implemented some kind of an incentive program where employees get a little kick in pay if they work faster, if they reduce contamination even more. But if the root origin of contamination is not the pick line, it's pretty difficult to incentivize folks to fix a problem that they have no control over. Again, the problem can be upstream or downstream of the actual MRF operation. We're seeing an increasing number of recyclers stepping back. Some reduce the range of commodities. They're just cutting back on certain types of diversion. Others are halting their program outright. They're completely stopping their recycling program. Here's a headline from the New York Times. More U.S. cities stop recycling. This is a common scenario. A number of our clients are telling us, hey, we have suspended our recycling program, or we're stopping specific parts of it because it is just not working. This takes us to our third poll question, and it asks, what is the current state of your diversion or recycling program? Number one, it's working well. We're diverting lots and making money. Number two, we've reduced our program slightly. Number three, we've made significant reductions to our program. Or number four, we have eliminated one or more parts of our diversion program. So again, the question, what is the current state of your diversion program? Number one, it's working well, making money, diverting lots of material. Number two, we've reduced our program slightly. Number three, we've made significant reductions. Or number four, we have just outright eliminated certain parts of our diversion program.
All right, great. You guys are getting to be pros at this now. So just to remind everybody, there's that questions tab on your GoToWebinar control panel. So if you have questions or even comments, if you want to share something about your facility or your experience on this topic, please feel free to jump in and do that, and we will review those and share any comments at the end of the webinar. So I still see some answers coming in. I'm going to give everybody just a little bit more time. And just to remind everybody, this is completely anonymous, so no one else on the webinar can see your answer, just in case that helps. All right, so a few more seconds here if you want to jump in. I'm still seeing a couple more participants putting in their answer. So I'll wait until that stops in case you really want to jump in on this. All right, I'm going to go ahead and close it out. Share those results. So we have 30% say that their program is working well and they're diverting a lot and making money. 50% have reduced their program slightly, and 20% have eliminated one or more parts of their diversion program.
Okay, well, kudos to the 30% who have a system that's working well, where they're diverting material and making some money. That's great, and I would venture to guess that that didn't happen by accident. I'm sure that you put a lot of work into making that happen. So good job with that. But the overall picture here is that 70% of us have had to make some reductions in our recycling, to the point of actually 20% actually eliminating parts of the program. So things are still rough out there in the recycling world. Even though some folks are doing better, it's still a tough game out there, and we're going to drill down to see how we can maybe make some changes with that. Some facilities are working, and so the poll results indicate what we're seeing out there, that some operations are doing better than others because they're producing cleaner material, they're doing it efficiently, they're marketing it well. They probably tend to know their operation pretty. They've probably done some of the things we're talking about in terms of drilling down to specifics, to be able to know what to change. But again, we have to define the goal. And today, this example is, the goal is, let's reduce contamination of our recyclables. So here's the goal, and this is that fishbone diagram. It's also a cause and effect diagram, and you can see why they call it a fishbone diagram. But we're going to go through and practice this just a little bit to give you a feel for this. This is something that is most effectively done in a group with your team or with other stakeholders. We'll often do this with clients when we come in to do a core assessment. We will often work with their group and go through some of these types of processes. There are many different kinds. This is just one example, one type, a cause and effect diagram. But the goal is listed in the box on the right. Excessive contamination of recyclables. That's our problem. That's what we're trying to solve. And we may have contributors, and this doesn't come from us always. Sometimes we will put topics in here when we're brainstorming with the group, but it often comes from your team, your laborers, your operators, your staff. They'll say, hey, we think we're having some problems. So we have the main heading, the main box at the right, excessive contamination of recyclables. And then we've got these headings along the top and along the bottom. And those might include the contamination, it occurs at the source or on the route or during the pre-sort, which would be like a floor sort type operation. Maybe it occurs during the sort itself at the MRF on the pick line. Maybe it occurs afterwards. Maybe we've got poor flow of material through the MRF, or we've got the wrong equipment, or maybe we're targeting the wrong commodities and we're doing something wrong with that. But these are big picture potential causes of contamination, and we list those on the top and the bottom. And so here's an example. I've kind of zoomed in to see the main goal or the main problem, excessive contamination of recyclables. And one of our potential contributors, contamination occurs during the sort. And we might say, okay, how can that happen? What's happening at the MRF that may be causing us to get some contamination? And so we might say, hey, maybe we don't have clear labels on the chutes. And so different people come in different shifts. They move to different stations on the pick line, and they're pulling a certain type of commodity, and they could be dropping it down the wrong chute. Maybe they don't know where it's supposed to go, or maybe they've got a bunch of barrels beside them for different things, and they're not tracking that effectively. Or maybe they haven't been properly trained. So you may have some folks that know the routine, but possibly if you have a lot of turnover, or you bring in temporary help, or you float people in from different parts of your operation to the pick line periodically, maybe they're not trained well, and it doesn't take a lot of mistakes. It doesn't take too many mistakes to create some contamination issues. Perhaps they're working too fast. Maybe you have been making a big issue about, come on, let's speed it up, and maybe they're working too fast and they're just making mistakes because they are trying to do too much too fast. Or maybe there's some hidden contamination. Maybe they're Maybe you're pulling cardboard and they're pulling pizza boxes that have pizza left in them, or maybe loads are coming in very wet and you're pulling cardboard, but there's other stuff stuck to it, or maybe loads are coming in and stuff could still be frozen. So you're pulling something out, cardboard or other types of paper or plastics or whatever, and there's something else frozen to it that was frozen in the can, in the load, and it's still frozen to it, and you're having issues with that. So these are just some examples, but the idea is we start with the big concept, excessive contamination. We try to identify some potential causes. One of those, contamination, occurs during the sort, and then we drill down, okay, what's happening in that sort process that could be causing that? And this forces us to drill down and get more specific. It's like solving a mystery. If you've ever played Clue, you know that you got to have specifics. You got to get some facts here so you know how to solve the case. And was it Colonel Mustard in the library with the wrench? You've got to drill down. You've got to get specifics to be able to figure that out. And so a cause and effect diagram, or a fishbone diagram, allows us to drill down to identify what those root causes might be. This is just simply a team exercise. It's a tool that we'll use to work through and try to drill down to some of the problems. And again, this is something that works great to bring your team in for a brainstorming time one day and talk about issues that you have. And it gets everyone thinking about that. Maybe you're having issues not on the pick line, but in the storage area. Maybe you're not maintaining good housekeeping at your bins or your containers where you're dropping different types of recycled materials. And so you've got spilled material on the ground and you open one gate to grab a certain type of material and it's all of a sudden now mixed with other materials and you have just created some contamination. After all your careful pick line work, you've contaminated because you're not managing your storage area effectively. So here's an example of a root cause. Trying to recycle too many types of materials. I was at a recycling facility and there was a public interface where the public could come in and drop off recyclables. And this particular recycling facility was trying to sort out several different types of plastic. And the public didn't know what it was. And there were pictures and examples, but they still got confused. So they actually, the recycling facility actually had staff out there. They had laborers out there helping every residential customer come in and sort through their bag of recyclables to put the right plastic in the right place, because if left alone, people would toss the wrong plastic in there, and instead of having a clean load of one type of plastic material, it would be contaminated with another type of plastic. And so sometimes a less complex system might work better. Hey, let's put all plastic containers here, or clear containers here and non-clear containers there. Keep it as simple as you can, because a simple process that works is better than a complicated process that doesn't work. There's another common root cause, trying to extract every shred of material instead of high grading. Let's suppose you're going after cardboard. A lot of cardboard can be pulled out on the floor because loads of cardboard may come in relatively clean, especially from box stores and other commercial operations. So some can be pulled out on the floor. Some can be pulled out as the initial extraction point on your pick line because you want to get that cardboard off the belt so everyone can see what's under it. That can be effective. But if you're trying too hard to get cardboard because maybe that's the only product that's generating any revenue, pretty soon you're reaching in for pieces of cardboard that are wet, or they're contaminated with food, or they're just inefficient to pull out because someone's picking fast, but they're getting small pieces of cardboard and they're just not generating much revenue because they're not generating much weight. Here's something to think about. If you've ever gone fishing, you know that the first fisherman at a good spot usually catches the big ones, and the more fishermen that show up, they have to try harder and catch fewer smaller fish because the good pickings go fast. On a pick line, it is the same way. The first few stations on a pick line can be very effective because they get to see everything and they can high grade. The more people you add, the more difficult it becomes. And so often we see this kind of a trend where one or two or three people on a pick line are just going for a specific commodity might do very well, but as we add more pickers, remember the pickings get a little bit leaner as material gets pulled off that belt. And so adding more people, on average, we can become less and less productive to a point where it doesn't make sense to add more people. So we need to be thinking about what we're trying to go after, and are we trying to pull too much of a certain type of commodity to the point where we're impacting our productivity. You also know that a lot of contamination comes from your routes. Some routes produce cleaner feedstock than others, and within any route, some customers produce cleaner feedstock than others. So if you're picking up cardboard from a box store, chances are you're going to get some pretty clean cardboard. If you're picking up cardboard from a restaurant or another type of store, you may tend to get more contamination in there because maybe the customer's workers don't pay attention to that. Maybe it's just inherently there's more contamination in certain types of businesses. And so being able to identify where that contamination is coming from and then tuning your routes can help minimize that. You could have a cardboard route that is great, brings up a lot of great material, and out of 35 customers on that route, 2 of them do a poor job of keeping contamination out. When you pick those 2 up and add them to the other 33, you've now got a contaminated load of cardboard. So tuning those routes and identifying where the problems are and either providing better education or just splitting those customers out and picking them up on a route that tends to have more contamination, you can keep things cleaner coming into your MRF, but you have to know where the stuff is coming from. Regardless of the source, the solution for eliminating contamination is the same. And these 5 steps right here come from some of the process improvement tools that we use. These in particular come from Six Sigma. I'm not going to get into that, but it's a specific process improvement tool, an efficiency tool. Basically, let's define what we're trying to accomplish. Let's measure what's actually happening and analyze that. Let's find some ways to improve it, and then let's find some ways to control it. And here are some of those tools that we'll use. Right now, on the right-hand column down toward the bottom, fishbone diagram, we've gone through an example of that. But we may tap into these other types of process improvement tools depending on what the problem is and how we need to address that. So all of these different tools and more may be applying to a core assessment or the analysis of figuring out what works. The core assessment is proprietary. So the tools we use, like Six Sigma, you can buy books on Six Sigma or Lean or Value Stream Mapping. You can buy books on that. Those processes are not proprietary. But the way we apply it is we've developed a lot of models and systems to use these tools over the past 30 years. And so there's something to that. One of the things, and once you determine how you want to modify your operation to improvement, you need to have some metrics to be able to track that. And we've got a couple of very smart guys in our company who are developing dashboards, and these are performance tracking dashboards to be able to monitor performance at a MRF or at a landfill or at a transfer station or whatever, to be able to identify and see it at a glance, in a snapshot, what's working with my system. And so those dashboards are a critical part of being able to monitor how's it going. You know what? I think we saw more than half of our group today said that we have contamination. We haven't done anything because we're not sure what to do. This is a critical part of that, to be able to identify what the solution is and then monitor performance so that we know we're working toward that. These are some common sources of contamination. Some are upstream, some may be happening at your MRF or at your recycling facility, but multifamily units where you pick up recyclable bins or containers or materials at a multifamily unit, it only takes one person to dump trash in the wrong bin, and now that load of recyclables is contaminated. Sometimes voluntary or unmanned recycling bins that may be at the grocery store or some other part of the community, maybe at the park, those can tend to have a lot of contamination as well. One source or one problem, one reason we have contamination is that we just don't have good education about recycling. Some people push it. So, give you an example. Worked with a community, and they had dialed back their recycling program, and they were not recycling glass anymore because glass had no, for them in their area, there was no market. It was difficult and caused some maintenance issues on their MRF or within their MRF operation, so they discontinued glass. And they let folks know, we're not recycling glass. Some of the folks, some residents, were demanding that glass be recycled, and the way they demanded it, they continued to put glass in the recycling bin, thinking that, hey, I'm going to put it in here, and the recyclers, they're going to have to recycle it no matter what, because I want to see glass recycled. So sometimes that education process, we've done a great job of telling people how important recycling is. There's another step to this, and that's to tell them how to recycle efficiently and recycle the right things. Food waste is going to be a very contamination-rich material. When we start integrating food waste into our organics programs, we're going to find that we end up with more contamination, more glass, more plastic, more trash mixed with that food waste, and very, very hard to separate that out. We talked earlier about the garbage bin pricing. We're talking about residential cans. If you're in a community that's trying to incentivize people to generate less trash and produce more recyclables by giving them a cheaper option to go with the really small garbage can, you may be indirectly creating contamination from that effort. Because again, if you push residents to a very small garbage can, either by only allowing that size or by allowing it or providing it cheaper than a larger can, folks will bite. They'll take that. They'll say, okay, great, I'm going to save money and go with the small can. But when it fills up, that excess trash is going to go in the recycling can, and you're going to have problems. So you need to weigh how you're pricing and how you're marketing all of this. Here's some recycling trivia for you, just kind of a couple things to think about. Contamination can be as obvious as leftover pizza in a pizza box. So if you're pulling cardboard out and your folks are pulling a pizza box, you know, if there's some pepperoni pizza rattling around inside that, that's contamination. But it can be as obscure as a broken Pyrex glass container, you know, those measuring cups, or, you know, the glass coffee pot that is made from Pyrex so it can withstand high heat. That material, if that breaks and that gets, or if it gets thrown in with your regular glass, it can cause problems because regular glass cullet melts at a certain temperature. And when they recycle glass, they'll melt it and reform other glass products. If you have some Pyrex glass in there, that material may not melt at that lower temperature that melts other glass. And so you can have, just imagine a Coke bottle that is made from recycled glass, and there's a little chunk of Pyrex in there that never melted. So now you've got this newly formed Coke bottle with new melted glass, and there's a chunk of Pyrex that really didn't make a part. It made a flaw in there. Under pressure or different times, that can cause that glass to break. So educating folks on what we can recycle and what we can't recycle is really, really important. We see people bring in plastic, maybe a kid's big wheel plastic tricycle, and say, well, it's plastic, or part of a dashboard from their car. Well, it's plastic. We just threw it in there because we thought you could recycle it. There's an educational component here. Here's another root cause where sometimes at a MRF or recycling facility, good loads, like let's suppose you have a front loader truck that's servicing box stores and it's running a cardboard route, and it comes into the MRF where you've got some source separated recyclables coming in, residential recyclables that include plastic and cardboard and metals and all kinds of stuff mixed on the floor. Here comes a really nice clean load of cardboard, and instead of that being tucked on the side and run separately or sent straight to the cardboard baler, it gets dumped and spread across all these mixed recyclables, and now you've just contaminated everything, and you've missed the opportunity to pull out a nice clean load. Everything gets mixed together. Often this happens because MRFs and transfer stations do not have enough room on the floor to do an effective floor sort or pre-sort. This takes us to our last poll question. How do you monitor inbound loads and adjust in order to minimize product contaminations? Number one, closely monitor different routes and adjust accordingly. Or number two, the ground crew visually inspects loads and there is some floor sorting. Or number three, we don't know the source of contamination. We don't do any monitoring. So again, the question, how do you monitor inbound loads of recyclables and adjust in order to minimize product contamination? Number one, we closely monitor different routes and adjust accordingly. Number two, the ground crew, the folks on the floor, visually inspect loads and there's some sorting that happens. Or number three, we don't know the source of contamination. There is no monitoring.
Okay, great. So this is our last poll question for the day, and I already see lots of you guys jumping in on this. So It's your last chance. If you have not yet voted on a poll question and you really want to, this is your absolute last chance for today. So just to remind everybody of a couple things, make sure you're sending over your questions if you have them in the questions tab on your control panel. We will send out the full recording of today's webinar. It usually goes out within a day or so after the webinar ends today. And then also just to remind those of you who maybe joined us late, we are doing a follow-up webinar next week on September 24th that's going to drill down even a little bit deeper into the overall operation of your MRF and how you can kind of look at the whole process a little bit more deeper. So Neil touched on some of this today, but we're just going to dive a little bit deeper next week. So we'll send out that link to register for that one as well. All right, I'm going to give everybody just a couple more seconds in case you want to jump in on this. All right, I'm going to close that out, and here are our results. So we have 25% are closely monitoring different routes and then making adjustments. 58% of us have ground crew that are visually inspecting the loads and then doing some floor sorting. And then 17% say that they don't really know the source of contamination, so there's not really a lot of monitoring that's going on.
Okay, well, this is interesting. I think we don't have time today to drill down with this, but I suspect that in poll question number 3, where we saw 30% of our group say that their recycling diversion program is working well, they're diverting lots, they're making money, I'll bet a lot of those same folks are the 25% here who say we're closely monitoring what comes in from different routes and we're adjusting accordingly. Maybe not all, but I bet there's a lot of commonality there because, again, the folks who know more about their operation are probably going to get better results. So 58%, more than half, are actually having their ground crew inspect loads, and there's some floor sorting. This brings me to something else. In most cases, and again, we don't have a poll question set up for this, maybe another time we'll do that, most facilities have inadequate room for a floor sort. But think about this. Think about the importance of a floor sort. Here comes a front loader truck that has just serviced box stores and has a load of pretty pure, pretty clean cardboard. 6 tons, okay? 6 tons of cardboard. If we dump that on the floor and there's no room to kick that to the side to keep it as clean cardboard, it gets put in with all the other mixed recyclables. It runs through the pick line. So we have 6 tons dumped on the floor. The loader could pick that up in a few grabs, put it in a cardboard baler, and we'd be done with it. Or we mix it with mixed recyclables. It goes up the conveyor, across the pick line. How long does it take your crew to hand pick 6 tons of cardboard after we have spread it out through our feedstock stockpile? A lot longer and at a lot higher cost than if we just took that 6 tons and put it straight to the baler or just did a minimal amount of floor sorting. That doesn't happen as often as it should because too often we just don't have room on the floor to do that. And this comes back to the folks that are building and designing MRFs is that they're focused on MRF equipment. Let's get the really jazzy, snazzy shakers and conveyors and sorters, and let's get all this great equipment. But really, if you want to do effective diversion, you need to have room to do a good floor sort because that's where you can get the most material for the least cost and the least effort. We miss that too often. All right. This whole concept about contamination affects organics too. Many of you are making plans or you're currently diverting food waste, and that means composting or some other process. You're going to learn a lot about feedstock contamination when you step into the food waste world. Here's an example about contamination in compost that you may not be aware of or that you may not have thought about before. Several years ago, Spokane, Washington had a compost operation. It was very effective, lots of organics there. But they made a great compost. It was nutrient-wise, it was a great material. But it had a very durable, long-lasting herbicide that made it through, that survived through the compost process. And this clopyralid, this particular herbicide, was not destroyed in the compost process. And so people took this really great compost and put it on their beans and their tomatoes and their peppers, and it killed them. just like applying herbicides. And as you can imagine, that was it pretty much killed the organics process for that community for a while as well. So contamination isn't just plastic and metal or food or whatever. It can be other things. In this case, it was an herbicide that lasted through the process. Compost also has problems many times with residual plastic, and we're talking about small pieces of plastic. So if you have a garbage bag, a large plastic bag in your feedstock, in your green waste pile, and you don't find a way to get that out before you grind everything up, now you've got thousands of pieces of plastic instead of one bag that you can pull out. This often comes back to public education, and it also comes back to your process. Do you need to grind first? Everybody has a process where they get in green waste, they maybe blend in food waste, they grind it, they compost it, they turn it a bunch of times, and then they screen it. By the time they've done that, they've taken every large piece of plastic and trash and they've turned it into thousands of little pieces that are hard to extract. And so, do you need to grind first? Can you compost first? Can you turn it in bulk with a loader and not grind it and let that thing go through the trauma so you can keep that plastic in big pieces where you can extract it? Different things to think about here. Food waste brings in other types of contamination. So I was involved in a project with one of the national parks, and they had a plan to create a compost operation for all of the national park food waste, and they integrated utensils, plates, cups, tableware, plastic forks and knives, and they weren't plastic. They were made from a biodegradable material, and the idea was that this material will biodegrade. The problem was it did not biodegrade in the short duration of time that was required to compost the other materials, the other organics, and so we ended up with this plastic tableware coming out and having to be screened out, and unfortunately a lot of it broke, and we ended up with a lot of plastic and leftover stuff there that would eventually decompose, but it didn't during the compost process, and folks don't like that. Broken glass contamination is a very visible problem, and compost is not supposed to have any sparkle to it. And when you are trying to market compost that has pieces of plastic or pieces of glass in it, folks who want to put compost on their organic tomatoes, they're not going to be very happy about that, and it's a very fickle market. The composting market can be very fickle. Once the word gets out to the master gardeners in your community that the landfill or the transfer station or the MRF or the organics processing facility is turning out compost that has trash in it, that's a very long uphill climb to get that market back. Similarly, farmers, landscapers, your bulk users, they also don't want that image. They don't want the image that their great compost has plastic and glass in it because that feels like trash. You have to work on this contamination even for organics. So in conclusion, contamination affects every type of diversion activity, whether we're talking about composting or a MRF operation or wood recycling or metal recycling or whatever that might be. The process of doing that can be impacted by contamination, and solving that requires that you drill down and find the root cause of that contamination. Don't just blame it on the pick line. Don't blame it on something that's easy. If you want to fix it, you've got to ask why, and drill down to that. So in recent projects, just as an example, we've seen clean loads of source-separated recyclables become contaminated by mixing with other materials on the floor, i.e. that nice clean load of cardboard. Or we've seen wood grinding feedstock contaminated with rocks and other debris that creates problems in the end use of that as a compost material or as wood chips, and also can cause equipment damage in the process. Or we see compost feedstock that's contaminated with plastic and trash, and depending on your process, again, if you're grinding that material before you do any sort, you are actually making it more difficult to extract that stuff. We have the next webinar coming up next week. We're going to talk about the same type of things, but we're going to focus on what types of commodities, if any, should you be targeting, and how you can decide which ones are going to give you the most diversion, the highest percentage of diversion, and which ones are going to be potentially generating the most revenue for you, and talk about some ways to implement some of those changes. So thank you for attending. If we have any questions, Sarah, this is a good time to go for that.
Okay, great. So we have one question that is asking about the cost of a core assessment.
It depends on the size of your facility and the complexity. So if you have a transfer station, MRF, you're transferring some waste to the landfill, some materials going through the MRF, maybe you've got an organics processing material, just ballpark. That can be $30,000 to $80,000 depending on the size and complexity. One of the things that we found is that we have never, ever, ever in more than 30 years conducted a core assessment where we did not identify more savings in the first year than the cost of doing a core. To the point that as a company, if you're thinking about doing a core assessment, we'll be glad to brainstorm with you, discuss your operation, and chances are we would guarantee that to the point where if we say a core is going to cost X dollars, we're going to guarantee that we'll find at least that much savings the first year, or we'll reduce the cost that we bill you. If we find zero savings, we won't charge you for the work that we did. So we're absolutely guaranteeing that the core is going to pay its way over the first year. And generally, if someone spends $30,000, $40,000, $50,000 to do a core assessment and all that goes into that, oftentimes the savings is in hundreds of thousands or even millions of dollars per year. So we'll guarantee that. We'll talk about that, but that's the range. It's going to be somewhere in that range to come in and do a core and identify issues, help you solve that, and get you set up on a good track.
Okay, great. So just to let you guys know, if you have questions that come up after today, or if you want to contact us for more information about a core review or any of these things we talked about, please feel free to reach out to us. It's probably best to go directly through me, and then I can get in touch with Neil. So my email again is Sarah, SARAH, @BlueRidgeServices.com, and I'm happy to get information to you or point you in the direction of an answer for what you're looking for.
So here's a follow-up on the core question. Pretty often, if someone is interested in a core assessment, we will gather some information from them and put together a customized for them webinar go-to meeting where we'll actually talk about what their issues are and how we would approach that and some potential savings that we would probably be expecting to see there. So if you're interested in doing a core, let us know. We'll send you a brief questionnaire and we can set a time to meet with your team, an online meeting just like this, and we'll go through and drill down into your specifics. We do that all the time. So that's something, if you're interested, let us know and we can set that up.
Okay, great. We don't have any other questions today.
All right. Thanks all. Be safe out there, and thank you for attending. Have a great week.
Thanks,
Bye-bye.
everyone.